Yeah, so we're going to use the Google Classroom to fill grades. Right now, of course, we don't have anything there. And but the way you join the classroom is when you sign on to Google Classroom, they need a class code, which this is what it is. HH366RX. If you type that in, you'll be fine. For example, let me copy that, okay? I use different account. Let's see for this one. And Google Classroom, type that in. Google Classroom. And okay. Okay. All right. We go Google Classroom. And if you want to join a class, you need to put that class, the code in there.
Okay.
Let me see why this one is kind of slow today. Let me check why is that. I don't know if this is my computer or something else. Uh, hmm. All right. Okay. So I already have that. So if and in your case, you need to put a class code to here. Let me try a different count, okay? And let's see if that would help get better that way. Um, okay, let me join the class. Okay, join a class. Now, so do you see that this is a plus sign there?
Mm-hmm. Yeah.
You see the plus sign here? So I clicked on that, and so there's called join class. So join class, and that's a class code. You see that. You just put it in, and then there is a join right here. Click that.
Oh,
And so you click in and wrong account. Well, in your case, if you click in, it should work, okay?
yes.
Right. I think this has to do with my other account. Okay, that's one for get to see your grade. And another thing we're going to do this year different, going to use something called Delta Math. I don't know, have you used that before? Have you heard of it? Delta?
No.
No, right?
Yes. I do. I have not heard of that.
Okay, all right. So let me see. I want to open up. Actually, Delta Math is pretty good way of doing homeworks. Okay, let me see. I should have that. My Delta Math. That's that. Okay. All right. So the first thing you're going to see is this page. If you type deltamath.com or you search for Delta Math,
Mm-hmm.
and you'll see this page. Okay, so
Okay.
deltamath.com. You see that. So for student, you click that inside, and there's a register, and here that's the class code. So once you join in, the class code, I'll give you the class code. after I explain how that works. So I'm explaining the homework. So once you get in, and here's what you see. Like in my case, I already we just use the login and use my Google account. So once I got in, I'll see I have several classes. One is this, and one is that. Okay, I'm just show you one of things. No, here, this is the homework. So you click on, and there's two in there. You can see that there's level 1, level 2. So,
Uh-huh.
and level 1 is called adding binomials. So you click in and you can see that work. So then you just type in 4x plus 2 plus 3x plus 5. 4x plus 7x is 4x plus 3x, 7x, 2 plus 5 is also 7. So that's our answer. And if you got right, it will show you that you got right. Good.
All right.
And also it shows you the process to do this. So you can see that we got 5. So this that's for when you are starting it. Once you know how to do it, you don't go through this model. So this is the model they use. So 5 ones, and there's 3 x's. So put x, x, x. Then you got 2 ones. Then you got 4 x's. So when you add together, of course, you got 7x plus 7. So is the answer. Good.
Yep.
Once you're done one, just go next problem. Now, if you made a mistake, here they said attempt 1 out of 2. So you got two times to try. So you got, say, I got wrong. Let's say I got 3x. Of course, the wrong answer. Put it in. That's okay. I verify it. Yes. Then I said, oh, it's wrong. So, and try to find your mistakes. You have 1 attempt remaining. Okay. So if you're not quite sure, there is a, you can see here, there's show examples. So say, okay, I'm not sure how to do it, but I can look at example and click that. See, okay, there's a example here, 3x plus 1 plus 3x plus 6. Okay, we got how many x? 6x. Then 1 plus 6, 7. Okay, now I got it. So if you're not quite sure, you can go to the next example. And if you're good, just to cancel it, then go back and try it again. So this time I'll say it's 2x plus 5. And we'll say, oh, good. So once you've done that, then you can see here is 60%. Once you've done that, you got 100%. Good.
Yep.
Okay. So now I'm give you the class code so you can just record it so you can give a try and go in. Okay.
Okay.
Okay. Now you can see in our case is the Poema Academy Algebra 1. So it's this, and the class code is here. It's U9NL-5GQ3. Good.
Yep.
Okay. Are you on the computer?
No, I'm currently on a phone.
Okay, that's fine. Okay, so just give it a try when you get a chance, okay?
Okay, I wrote it down.
Yeah, if you need help, let me know, okay?
Okay.
Yeah. All right. Okay, let's start today's lesson. Today, since we are doing Algebra 1 now, I mean, you have done pre-algebra with me before.
Yep.
So we are going to basically start right away with algebra. Normally, if I don't have student I have not taught before, I'll start kind of with integers and fractions, but I think you are good with that. Okay, so we got into variables. That's what we're doing, and what we do with variables. So first of all, variables is actually quite often we have. For example, now say if you have 3 bags of candy, and maybe your friends have 2 bags of candy. Now, how many bags of candy do you have?
What did you say?
So you have 3 bags of candy, and your friends have 2 bags of candy. So together, how many bags do you have?
5 bags.
5 bags, right? So now we don't know how many candies in each bag, but in this case, it really doesn't matter because we're just interested in bags. How many bags, right?
Mhm.
Now, if we just say how many candies, that's a different story. We need to know how many candies that in the bag. So the variable is kind of like that. So you can look at variable as a bag, and the value, we call the value of the variable is, in this case, kind of like how many candies in your bag. You could have 10, you could have 15, you could maybe 20. So the bag's still the same bag, but you could have different number of candies. So that's why we call that a variable. It changes, the value changes, but the bag's still just one bag. Good?
Yep.
So therefore, when you're looking at down here, when you do something like say 2x plus 3x, that's just 5x, just like 2 bags candy plus 3 bag candy, 5x, or 7x minus 3x. You got 4 bags of candy and someone took away 3 bags, then you have 4 bags left. So that's what we got.
Mhm.
Good?
Yep.
Make sense?
Yep.
Okay. Now, if we have say 5x plus 3y, then we have different variable, and that we cannot add. So this is kind of like you got 5 bags of candy and 3 boxes of bananas. So you cannot really add them together. But you have like say 3x plus 2y add 5x plus 3y, then we can combine them. This is then 3x plus 5x is 8x, then 2y plus 3y is 5y. So we can actually combine them into just 2 terms. So that way, and this is as far as we can go, unless we know the value of x and value of y. And so normally when we see x and y different letters in the same, this is the same sentence, it means different things. Good.
Yep.
Okay, and similarly, when you see something like 3x squared plus 5x plus 7x minus x squared. Now, we can only combine 5x and 7x. Those are called like terms. Now, we cannot, so x squared plus x, we cannot combine them. And we know x squared just means x times x, right?
Yep.
So, but x squared and x, they are different things. So we cannot combine them. So in this case, then we know we can 5x and 7x are like terms. Then 3x squared and x squared also like terms. So we got 5x plus 7x, 12x, 3x squared minus 1x squared. We got 2x squared. Good.
Good.
Very good. So now we're going to learn some terminologies when we're dealing with those symbols put together, and those are called polynomial, polynomial, expressions. So when we say expressions, it's kind of like saying part of a sentence, not a whole. Like say, nice cat. As part of a sentence, not a whole sentence. Whole sentence will be, I saw a nice cat. Then that's a whole sentence. So in math, similarly, when you have expression, for example, 2x plus y, we call that polynomial expression. And that is not complete sentence. Until we write 2x plus y equal to 7, then we have an equation. So that's the difference between equation and expression. Good?
Good.
Okay. Now, in terms of expressions, polynomial. Now, polynomial, they made the two words, poly. Poly means many, nomial means term. So many terms. Now, the term we count is when we have equals add or subtract sign, then we got one term here, one term here. It's two terms. One term's here and one term's here, two terms. But if you have, say, we got something like this, we got 1, 2, 3, 4 terms. Okay. Now, if you only have one term, which say 3xy is one term, or 7 y times z to the third, and those are considered just one term because there's no add subtract. And this is called monomial. Mono just means one. Now, if we have two, like 3x plus y or 7x squared minus 5x, those we have two terms, and those are called binomial. Bi just means two, binomial. Of course, we could have three. Now, if we have three, it's called trinomial. So, but what happens if we got four or more? Then we just call them polynomial. That's many terms. Good?
Good.
Okay. Once we have that, now we're looking at, how do we add or subtract polynomial expressions, which we already did a little bit early on. But now we're going to see, we're going to do a little bit more. So 7x plus 2 and plus and 5x minus 3. Now we can see that this is a binomial expression. This is another binomial. So that's the addition of two binomial expressions. We know that 7x and 5x are like terms. So 7x plus 5x, and like 7x plus 5x, got 12x. So we got 12x. Number is easy, we just add them, but it's 2 minus 3, so that should be actually give us -1. And we can write as 12x minus 1. Good?
Good.
Now, we could also have, say, 3x minus 5 plus 7x plus 2. And then we can see that, first of all, we just open up the parenthesis. And now we see that 3x and 7x are the like terms. So we got 10x here, minus 5 plus 2, -3. So we got 10x minus 3. Once we got here, because we don't know the value of x, so that's as far as we can go. Good?
I'm good.
Okay. So I'm going to let you try a couple, okay?
All right.
So 3x plus 7 plus 5x minus 6. Let's see what you got. So it's just on the chat. You can put down. Check. Yeah, you can just type on the chat.
Okay.
Perfect, very good. Let's try one more. 7x plus 3, then plus 4x minus 9. Perfect, good job. Okay. Now we're going to move on to subtraction, okay? So I will do subtraction. So 7x plus 2, if we minus 5x plus 6. So now this, we can just open it, no problem. But when we have minus here, and that is the same as add -1 times 5x plus 6. So that one got distributed. So now we got to here, we got minus 5x. To here, we got minus 6. Then, of course, we combine them, we got 2x minus 4. Good?
Yep.
Perfect. And then, if you have to say 7x squared plus 5x plus 2, then minus 2x squared plus 7x minus 4. Then we got 7x squared here plus 5x plus 2. And that got distributed. And we got minus 2x squared minus 7x plus 4. Okay, now we can see this plus this. Both have x squares. So that's the like term. We got 5x squared. Then 5x minus 7x, so it's minus 2x. Then 2 plus 4, we got 6. And so now we got this. Good?
Good.
Okay. So I'll try a couple of those, okay?
Okay.
So let's do something simple one first. 7x plus 9 minus 5x plus 6. That's what you have. Okay, so we got 7x plus 9 minus 5x minus 6. So we got 2x plus 3. Good?
Good.
Okay. Try. 5x minus 7 minus 9x plus 2. Let's see what you have. Well, let's see this one. Okay, make sure the sign 5x minus 7 minus 9x minus 2. Now, 5x minus 9x, you got that right. But here's minus 7 minus 2, so it'll be minus 9.
Okay.
Okay, let's try a couple more, okay?
Okay.
So minus 3x minus 7 minus 2x and minus 4. Okay, let's see. We got minus 3x minus 7 opening up. But when we open this up, this got distributed. So it's minus 2x and negative times negative positive plus 4. So, but negative 3x minus 2x get negative 5x. Then minus 7 plus 4, negative 3 or minus 3. Good?
Good.
Yeah, to make sure the sign you work on this. Now, of course, we can do more than just 2 terms. We could have like 3 terms. For example, we could have 3x squared plus 5x plus 1 minus 2x squared plus 7x, then minus 5. And then we just combine them and see what you got. So the way to type x squared in the chat, you just do x, then there is a hat symbol, then you put 2 there. Good?
Mhm.
Yeah. Okay, so here again, got to be careful with the sign. We got 3x squared and plus 5x plus 1. And then we open this up, that becomes minus 2x squared minus 7x, then plus 5. Okay, negative, negative, and positive. Then 3x squared minus 2x squared, we know it's x squared. Think about 3 boxes, then take away 2 boxes. But 5x minus 7x is minus 2x. And then 1 plus 5 here, there's 1 here, there's 5 here, both are positive. We got 6.
Okay.
Okay, let's try. Okay, now we're going to try different variables. So could have 5x plus 4y plus 3z, and that minus 7x and minus 3y, then plus 7z. Good?
Okay. Good.
Okay, let's see that again. I think I still make the mistake uh on this, to pay attention to the sign, okay? So
Mhm.
first one is 5x plus 4y plus 3z, then minus 7x, and so that got distributed. On here, we got 3y, then on here, we got minus 7z. Then we're going to look at 5x and negative 7x is negative 2x. You get that right. 3y plus 4y plus 3y, that's 7y. Then 3z minus 7z, which is like 3 minus 7, that's minus 4z.
Okay.
Okay. All right. Now we're going to looking at 5x plus 7y minus 3z. Then that whole thing minus 3x plus 9y and minus 5z. Okay. Okay, let's see. 5x plus 7y minus 3z. Then let's get in here what we see. Minus 3x minus 9y and plus 5z. So what we got? 5x minus 2x. You got the first one right. Now 7y minus 9y, you got that right too. But minus 3z plus 5z, that should give us 2z. So that should be that. Good?
Good.
Okay. Right. Yeah, just practice and you'll be all right. Okay, let's just our last one to practice on that, okay?
Okay.
So once you're done, you can actually double checking it and see if it's correct. Okay. All right. We got 3x minus 7y plus 5z minus 7x minus 2y minus 7z. Okay. You can see that 3x minus 7x, you get that correct, minus 4x, and but negative 7y and minus 2y, that should be minus 9y. Then you got the z correct. 5z minus 7z will be negative 2z. Good?
Good.
Okay. Yeah. So you can just practice. While you have homework, you can do the practice on that. Okay.
Okay.
Now we're going to looking a little bit more. So since we are talking about variables, and now you know how to do addition and subtraction of polynomial expressions. So we're going to looking at a bit about multiplication and division. So when we do multiplication, say 3 times 2x. So what do we mean by that? Well, you can think about this 2 bags, and you get 3 people. Each one have 2 bags. So therefore we got 6. So makes just simply a multiplication of numbers. We got 3 times 2, we got 6x. So we got 4 times 7z, which is simply 28z. Good?
Good.
Okay. And then what happens if you got, say, 3xy times 5y and z? Well, then we just number times number, 15. Then we only just one x, okay, x. Now y, we've got 2y now, so that will be y squared. And we'll have 1z, so that's what we end up with. Good?
Good.
Okay. Have you tried couple, okay?
Okay.
4x squared y times, you use dots for the times, and 3 and xz. See what you got. Okay, so actually, good. You got 12 correct, 4 times 3. But you can see here is 2x squared and times x. Now we have 3x multiplied. So it's x to the cube, then y and z. Good?
Good.
Okay. And now let's do 4xy z times 7xz. Okay.
Okay.
Okay, good. We got 24, 28. How many x? We actually got one x and two x. So it's x squared. We only got one y, but z, we got two, just like you write down there. So z squared. Good.
Good.
Okay. Now let's try one more. Okay. So you pay attention to the how many variables we got. So 3x squared y z times 5x y to the third times z to the fourth. Okay, we got 15. Very good. And how many x? 2x here. There's another. So x to the third. And you got the y correctly. Good job. We got 4 y's. Then we got 5 z's. Good.
Good.
Okay, now we're going to looking at the division. So what do we mean when we have, say, x divided by x? Well, what that should be? Well, let's see. We just x is a number by itself. That should be 1, right? Because 3 over 3 is 1, 5 over 5 is 1, and even -3 over -3 is still 1. So x divided by x is 1. So therefore, when we have x squared divided by x, well, x squared, we got 2x there. And so then this we call, so x divided by x is 1. 1 times x is x. So what's really going on is we rewrite this as x times x over x, then just x times 1, which is x. So that's why we say we can cancel this 2x. So x squared divided by x, we got 1x. Now, sometimes if we got something like, say, we got 4x divided by 4, and next is the number divide, so then that give us x. Good?
Good.
Okay. Let's try 15x divided by 3. Yep. Then 21x divided by 7x. Very good. So now we're going to a little bit give you a challenge now. 14x squared over 7x. Well, now we know 14 divided by 7 is 2. That's good. Then x squared over x. What's that? Well, x squared just x times x. Now both divide by x. So that got canceled. Then we got 2x.
Okay.
Okay, and now let's see. So we got to Q. Very good. Yep. So 2x squared. Now, sometimes we won't be able to have it's not divisible. So we could have something like this, 14x squared over say 6x. So now 14 and 6, we know we can common factor of 2. So then we got 7 and 3. And now, so we got 7x squared over xx. So we got 7x over 3. Good?
Good.
Okay. Okay. Well, we're we're not going to turn into a decimal. We just keep that as whole numbers. So we know 28 and 24, they have their greatest common factor is 4, because 28 is 4 times 7, and 26 is 4 times 6. 24, 4 times 6. Now we got x square and x, so we can separate them out, and y over y. So you got, so we got 7 x, because x squared divided by x is x, and over 6. Good?
Good.
Yeah. You can see that we just number divided by number, symbols divided by symbol. We're still looking at the pretty much the same symbol we can divide. Okay. So let's try one more. 35 x cubed times y squared and over 40 and x and y. Okay.
Mm-hmm.
Very good on the symbols, but we know that 35 is 5 times 7. Very good on the variables. X cubed divided by x is x squared. Very good. And y squared divided by y is y. Perfect. But 40 is 5 times 8. So therefore we got 5 cancel. We got 7x squared y and over 8. Good?
Good.
All right. Let's just try 2 more, okay?
Okay.
10 x y squared and over we got 30 and x and y. Oh, very good, but close. So you got 2y and 6, but also we can simplify further because 6 is 2 times 3. So actually we got y over 3. Good?
Good.
Very good. So our last one, okay?
Okay.
Okay. Well, let's see. You're pretty good now with variables, but still struggle with numbers. So you got variable right. But 36 is 4 times 9. And so x squared, 4xy squared. Then 27 is 3 times 9. Okay. So now 9 and 9 cancel. We got the same thing. Then we got 4xy squared and over 3.
Good.
Right. So that's all we have today. So make sure you go to the Google Classroom and also the Delta Math. Okay.
Okay.
All right. See you next week.
See ya.
Bye.